continue on here, we're going to look at solving systems of three equations with three unknowns. So we could have the situation where these three planes hit it at one spot, so consistent system with one solution right there. So it's at one spot, so that would be our x, y, z point would be the solution. We could have no solution, an inconsistent system, so the planes are parallel, or we could have infinitely many solutions, so there could be infinitely many pairs that satisfy the system of equations. Okay, so let's go ahead and use elimination to solve this system of equations here. What I'm going to do here first is I'm going to take 1 and 2, and I'm going to get rid of equations 1 and 2, and I'm going to get rid of the y's. Okay, so up here I have negative 2y, so I need this to be 2y. So I'm going to multiply this equation by 2. Okay, so what I'm going to have with equation 1 stays the same, x minus 2y plus 3z equals 7. Equation 2, multiply everything by 2. Come on. Equation 2, and I've got 4x plus 2y plus 2z equals 8. My y's are gone, so I got 5x plus 5z equals 15. So what I did is I got rid of the y, okay, with 1 and 2. Now I need to use equation 3, and I can use, and I want to get rid of, so I eliminated y in my step here. So, and now I need to use the remaining equation, and I also need to eliminate y. And I can pick either equation 1 or 2. It doesn't matter. But I have to use 3. I'm going to use equation 1 with equation 3. So equation 3, have to use this. And I have to get rid of y. Again, I'm going to use equation 1 because it's easy. It naturally eliminates the y. See how those are gone? I don't even have to multiply by anything. Alright, so let's add these up. X minus 3x, negative 2x. I've got plus z equals negative 3. And I'm going to call these equations A and equations B. So now what I'm going to do is I'm going to use equations A and B, and I'm going to eliminate a variable with each of those. So equation A, so I'm going to treat it like two linear equations and two unknowns. So I do the exact same things we were just doing before. Looks 5x plus 5z equals 15. I've got negative 2x plus z equals negative 3. And so what I'm going to do is I'm going to multiply, let's get rid of the z's. So here's 5z. I need this to be negative 5z. It's positive 1z right now. So let's multiply it by negative 5. And let's see what we get. Okay, so equation A stays the same. 5x plus 5z equals 15. Equation B, we multiplied by negative 5. Whoops, negative 5. Multiply. My goodness. Multiply by negative 5. And I get 10x minus 5z equals 15. Notice the z's are gone, so I got 15x equals 30. So my x is 2. Yay! I know my x is 2. Big step. Now what I do, now that I've eliminated, or now that I know one of the variables, x is 2, I go back to either A or B, either of those. I'm going to take B, so now that I know x is 2, let's take B. Negative 2x plus z equals negative 3. Negative 2 times 2 plus z equals negative 3. So negative 4, so I'm going to add 4 to both sides. So I get z equals 1. Now I know z is 1. So I know x is 2, 2 z is 1, and I need to know y. So I can go back to any of the original equations, 1, 2, or 3. I'm going to take x minus 2y. I'll just take the first one, plus 3z equals 7. X is 2, don't know y. Z is 1. I got 2 plus 3, I got 5. So 5 minus 2y equals 7. Subtract 5. Negative 2y equals 2. Divide by negative 2, I got negative 1. So x is 2, y is negative 1, z is 1. X, y, z. So 2, negative 1, 1. And what we can do is you can go back and you can check those into the original solution there. Okay? Alright. Now let's do example 10 here. And I'm going to get rid of, let's take 1 and 2, and because I can get rid of my z's. Okay, so let's eliminate, oh my goodness, I can't spell z, with 1 and 2. It naturally eliminates. So that's gone. I've got x minus y equals 5. Okay, so x minus y equals 5. I'm going to call that equation A. So now I have to use equation 3. I have to use equation 3, the one I did not use. And I need to eliminate the same variable. So since I need to eliminate z with it, let's take equation 2 along with it. And again, I could have used 1 or 2. But notice those are gone. So I have 2x minus 2y equals 6. That's I'm going to call equation B. So now I'm working with A and B. I have two equations, two unknowns here. X minus y equals 5 and 2x minus 2y equals 6. Let's go ahead and get rid of the x's. Here, let me write it up here. A is x minus y equals 5. B is 2x minus 2y equals 6. I'm going to get rid of the x's. This is 2x. I need this one on top to be negative 2x. So I'm going to multiply both sides of this equation by negative 2 so that I get negative 2x plus 2y equals negative 10. Bottom is the same still. 2x minus 2y equals 6. And notice that's gone. Oh my goodness, the y's are gone. So we got 0 on this side. Equals negative 4. So then you sit back and say, well, my variables are gone. Is this a true statement? No, it is not. So just like two equations, two unknowns, this has no solution. This has no solution. Okay? So again, algebraically, that's how you're going to know. That is definitely not true. All variables are gone. You have an untrue statement there. Those things never intersect, those planes. All right, how about, oops, that's still example 10 here. This scenario, example 11, solving systems dependent equations. So let's go ahead and take let's take 1 and multiply it by 2, and let's get rid of. So let's do 1 and 3. So 1 and 3, but I'm going to multiply this one by 2 so that I get rid of my z's. So I get rid of my z's. So what I have here, once this all goes through, is I have, so equation 1 becomes 2x minus 2y plus 4z equals 2. And then I have equation 3 I don't have to touch. Z's are gone. So I have negative 6x plus 9y equals negative 15. Okay, so I'm going to call that equation A. Whoops, equation A. So now I need to use equation 2 I need to use equation 2. And I need to eliminate the same variable. I need to eliminate z. So I want to get rid of negative 2z. So I'm going to use equation 1 with it, since it'll naturally eliminate. X minus y plus 2z equals 1. See how that's gone? So I got 2x minus 3y equals 5. So now I'm left with a and b. So a, I have negative 6x plus 9y equals negative 15. B, I have 2x minus 3y equals 5. And let's get rid of the y's here. Now let's get rid of the y's. So 9y's on top. I'm going to multiply this by 3, so I have negative 9y. So that becomes, again, the top stays the same. Bottom becomes 6x minus 9y equals 15. See how that's gone? The y's are gone. The x's are gone. So we got 0 equals 0. This is a true statement. So what this means is we have we have a dependent system, but infinitely many solutions. So we have infinitely many solutions here. But we're going to be more specific about this. Yes, we have infinitely many solutions. But what we're gonna do is we're gonna take A or B. It doesn't matter. We can solve for y. So we can write the solution to the system as. So if I solve this for y right here, divide by negative 3, I get 2/3 x minus 5/3. So the solution, you can write this as y equals 2/3 x minus 5/3, where x is any real number, okay? And then what I'm going to do is I'm going to plug that into this y equals 2/3 x minus 5/3. I'm going to plug it into equation 1. Sorry, I'm kind of running out of room. X minus y plus 2z equals 1. So x minus y, plug y in. So I got x minus 2/3 x. So that's 3/3 x minus 2/3 x. That's 1/3 x. And then negative times negative 5/3, 5/3 plus 2z equals 1. Subtract 5/3 on both sides, so that's 1 minus 5/3. What I'm doing is I'm solving z for x here. And then I subtract 1/3 x on both sides. So this ends up being, and then divide everything by 2. This ends up being negative 1/6. Sorry, I'm running out of room here. Negative 1/6x, that'd be minus 1/3. And that's your other one right here that you'll write it as. Z would be expressed as negative 1/6x minus 1/3, whatever x may be. So that's how you describe that dependent solution set, so that has infinitely many solutions there. Okay? Here's your in set notation if you want to write that x, y, z such that x is any real number. Okay. All right. Let's set up some now. We're not going to finish these off, but we are going to set these up. So you've kind of seen a couple of these story problems. A canned juice drink is 15% orange juice. Another is 10% orange juice. How many liters of each should be mixed together in order to get 5 liters? So let's say x is the number of liters at the 15% concentrate. Y is the number of liters at the 10% concentrate. And we know they add up to get 5 total liters. All right, so we know that. Now, what about the mixture? Well, we have a 15% concentrate times X number of liters mixed with, so added together with, 10% mixture, however many liters of that. And that's got to give us a 13% mixture, but there's 5 total liters. Okay? And then you can just do this by elimination, right? So if you were to do this by elimination, and let's say you were to eliminate y, then you'd multiply this by negative 0.10, right? Everything, you'd eliminate y. Anyway, soon enough, I'm not going to go through all that. We've done some of these examples, but you'll need 3 liters of the 15% mixture if you want to check yourself on this, and 2 liters of the 10% mixture. Let's do another one. This is a distance, rate, time situation with a tailwind. A small aircraft can fly 1,050 miles in 5 hours against the wind. The plane, whoops, typed that wrong, can fly the same distance in 7 hours. Find the average wind speed and the average airspeed of the plane. So if you have with a tailwind, so you have that, it's aided, right? Distance equals rate times time. You go 1,050 miles at whatever rate your airplane's going, but with the wind, I'm going to call W the wind speed, times time. You do this in 5 hours. Now against, I'm struggling with my spelling today, then distance equals rate times time. You still go 1,050 miles, but it's against it. You're fighting it against the wind there. And it takes you longer. It takes you 7 hours. Okay, so what you have here is you have 1,050 equals 5r plus 5w. You have 1,050 equals 7r minus 7w. And then you can just solve that by elimination or substitution, or however you want to solve that. And you'll end up, your rate, airspeed of the plane ends up being 180 miles per hour. And then the wind speed, it's either with you or against you, ends up being 30 miles per hour. Okay? So that's a couple setups there. You'll have some story problems. Thanks so much for listening. We'll see you guys next time.